Every year, American gardeners spend over $50 billion on fertilizers that stop working the moment they stop buying. Bags of nitrogen that vanish in rain. Phosphorus that locks itself into soil and never reaches a root. Meanwhile, 7 soil amendments used by ancient civilizations for thousands of years can permanently transform dead soil into living, productive earth for less than $100. The synthetic fertilizer industry generates $230 billion annually by making sure you never learn their names. The record opens in the Amazon basin around 450 AD. Researchers excavating ancient settlement sites found soil so black, so impossibly rich, that it held its fertility 1,500 years after the civilization that created it had vanished. They called it terra preta. Carbon dating confirmed it was deliberately built. The knowledge of how was never written down, but the soil itself was the document. So what happened to that knowledge? In 1909, a German chemist named Fritz Haber synthesized ammonia from atmospheric nitrogen and created artificial fertilizer. Within a generation, ancient soil wisdom was buried under bags of nitrogen, phosphorus, and potassium. A $230 billion industry was born, built on a single myth that your soil needs what only they can manufacture and sell. 3 nutrients out of 17. The pantry is full, but the door is locked. A 2025 meta-analysis tracking over 40 controlled studies confirmed the right combination of amendments can boost yields by 39% and soil organic carbon by 62% in a single season. The knowledge was never lost. It was simply made inconvenient to find. Until now. Here are the 7 amendments they never told you about. Amendment 1. Biochar. The ancient carbon secret. Somewhere in the Amazon, a civilization deliberately built the most fertile soil on Earth and then left. What they left behind was not stone or gold. It was carbon. Modern archaeologists studying terra preta sites found that the ancient black earth contained deliberately placed biochar, the charred residue of organic material burned under low oxygen conditions through a process scientists now call pyrolysis. The resulting carbon structure is architecturally extraordinary. 1 gram of biochar contains a surface area equivalent to 2 tennis courts. That internal architecture does something no synthetic fertilizer can replicate. It houses life. A 2025 MDPI review confirmed that biochar-amended soils show reduced nitrogen requirements, improved nutrient bioavailability, and enhanced microbial activity across multiple soil types. A meta-analysis found biochar-amended compost boosted plant productivity and soil quality by an average of 44%. A 2021 Frontiers review of large-scale field trials demonstrated biochar reducing soil bulk density by 3 to 31%, while improving fertility markers consistently across climates and soil types. The mechanism is threefold. Biochar provides habitat for beneficial microbes that break down organic matter and make nutrients available to plant roots. It holds water and dissolved nutrients in its porous channels, releasing them slowly rather than losing them to runoff. And it creates air pockets throughout the soil matrix that prevent compaction and allow roots to breathe. Apply biochar once at 10% by volume into your top 6 inches of soil. You will not apply it again. The terra preta sites in the Amazon are still producing today, 2,000 years after the last human hand touched them. Amendment 2. Worm castings. Biology measured in billions. The fertilizer bag in your garage tells you 3 numbers. It does not tell you what is absent. Worm castings contain 5 times more nitrogen than ordinary garden soil, 7 times more phosphorus, and 11 times more potassium. But none of those figures explain why worm castings outperform fertilizers with far higher NPK ratings. The explanation is not chemistry. It is life. A 2025 Science Direct systematic review confirmed that vermicompost enhances nitrogen fixation and crop yields across multiple food categories. A 2023 MDPI study documented worm castings improving nutrient availability while increasing plant tolerance to pests and disease. Research from LSU Ag Center documented specific micronutrient profiles in castings that support plant immune function in ways no synthetic product replicates. Each gram of high-quality worm castings contains billions of beneficial microorganisms, bacteria, fungi, and protozoa that form symbiotic relationships with plant roots and improve nutrient uptake by up to 40%. They also produce humic acid, which improves soil structure and helps plants absorb minerals more efficiently. Worm castings are pH neutral. They cannot burn plants regardless of application rate. And unlike synthetic fertilizers that spike and crash, the microbial populations they deliver remain active through an entire growing season. Mix 25% castings into new beds. Top-dress established beds with a half-inch layer each fall. Or build your own worm bin for $50 and produce castings indefinitely from kitchen scraps. The ancient Amazonian farmers composted their organic waste directly into the soil. They were building biology, not feeding numbers. Amendment 3. Gypsum, the clay unlocking mineral. If your soil is heavy clay, you already know the punishment. Rock hard in summer, suffocating wet clay in winter, and roots that spend their entire season fighting soil structure rather than growing food. Synthetic fertilizers applied to clay soil face the same problem your roots do. The nutrients cannot penetrate. The pantry is full, but the door is locked. Gypsum, calcium sulfate, works at the particle level. Calcium ions bind to the flat, tiny clay particles and force them to aggregate into larger clumps through a process called flocculation. Those aggregates create pore space where air can flow, water can drain, and roots can push through without resistance. Ohio State University Extension documented gypsum improving soil sulfur, calcium, and crop yields in low sulfur fields. Cornell University confirmed structural and nutrient supply benefits. Michigan State University Extension documented gypsum reducing aluminum toxicity in soils with low pH while improving water infiltration in sodic conditions. A Purdue University analysis confirmed gypsum's effectiveness for specific clay profiles where other amendments fall short. The critical distinction from lime is pH neutrality. Lime makes soil more alkaline. If your soil is already neutral or slightly alkaline, lime creates new problems while fixing none. Gypsum delivers calcium and structural improvement without touching pH at all. Apply 40 pounds per 1,000 square feet, worked into the top 6 inches. Within a few weeks of rainfall or irrigation, you will notice the difference in how the soil feels under your hands. Amendment 4. Green sand, the ocean mineral library. 100 million years ago, ancient shallow seas deposited a mineral-dense sediment called glauconite across what is now the American Midwest and Eastern seaboard. That same mineral, mined today as green sand, contains iron, potassium, magnesium, and over 30 trace minerals that plants require for functions far beyond what NPK can support. The problem with modern fertilizers is not what they contain. It is what they omit. Iron is required for chlorophyll production. Magnesium is the atom at the center of every chlorophyll molecule. Manganese activates the enzymes that drive photosynthesis. Zinc is essential for the synthesis of growth hormones. Without these, plants show deficiency symptoms even when NPK levels register as perfect. Yellow leaves, stunted growth, hollow fruit, and poor seed set. It is a locked door, no matter how much you pile against it. A 2025 ResearchGate study confirmed that glauconite enhances soil fertility and water-holding capacity across soil types. A 2025 PubMed study documented glauconite compounds improving saline soil properties and significantly boosting crop yields compared to synthetic control plots. Because green sand releases its mineral content slowly over 3 to 5 years, a single application builds long-term soil fertility rather than a seasonal spike that crashes after rain. Green sand works in synergy with the biology amendments. The microorganisms in worm castings and activated compost help break down glauconite particles, making minerals available to roots far faster than green sand applied to biologically dead soil. Apply 50 to 100 pounds per 1,000 square feet once every several years. You are not feeding this season's plants. You are building the soil library that feeds the next decade. Amendment 5. Azomite, the volcanic trace mineral archive. 60 million years ago, a volcano erupted in what is now central Utah. The ash settled into an inland sea. Minerals concentrated. Over millions of years, the deposit transformed into one of the most chemically complete mineral substances in the geological record. We now call it azomite, a name derived from A to Z of minerals, including trace elements. That name is accurate. It contains over 70 naturally occurring elements in forms that soil biology can process and deliver to plant roots. Modern NPK fertilizers address 3 nutrients. Complete plant health requires 17 essential elements, plus a spectrum of trace minerals. When trace elements are absent, the cascade of deficiencies is specific and damaging. Boron deficiency causes hollow stem in broccoli, cracked fruit in tomatoes, and failed seed development across dozens of crops. Molybdenum is essential for nitrogen fixation in legumes. Without it, even soil rich in nitrogen cannot support healthy bean or pea production. Selenium, cobalt, and vanadium, present in traces that soil tests rarely measure, support plant immune responses and enzyme activity that synthetic chemistry has never successfully replicated. Research published in the Journal of Sustainable Forestry documented volcanic ash as a multi-nutrient fertilizer, showing measurable and consistent crop improvements across test sites. A study published through Semantic Scholar confirmed azomite modulating gene expression in plants through phyto-B pathways, a mechanism that affects growth, resilience, and nutrient use efficiency at the cellular level. Apply 5 to 10 pounds per 1,000 square feet once per season, incorporated into the top few inches of soil. Because the particles are extremely fine, mineral release begins almost immediately. For less than a penny per square foot, you deliver the complete mineral spectrum that volcanic soil has provided to the world's most productive agricultural regions for thousands of years without the volcano. Amendment 6. Activated compost, the living soil accelerator. Compost alone is valuable. Compost activated with biochar and inoculated with worm castings becomes something categorically different. The distinction matters because biological systems compound. Biochar in compost provides the physical housing for microbial colonies. Biology from worm castings introduced into that housing creates a self-sustaining microbial ecosystem. Compost itself provides the food supply that keeps that population thriving through the entire growing season. The research confirms what the combination produces: A meta-analysis found that biochar-amended compost boosted plant productivity and overall soil quality by an average of 44%, significantly outperforming either amendment used alone. A 2024 PMC study confirmed that enriched and activated compost amendments improve soil fertility markers and crop yields beyond what standard compost achieves. A 2025 Wiley publication linked organic amendment applications directly to measurable yield increases in multiple field environments across crop types. The deeper principle is the direction of effect. The synthetic fertilizer system is designed to degrade over time. Soil biology dies under continuous synthetic inputs, requiring more inputs to maintain the same output. Each season, the dose must increase. Activated compost works in the opposite direction. Each application improves the biological baseline for the following season. You build a soil that needs less over time, not more. That trajectory is the opposite of dependency. Apply 3 to 4 inches of activated compost across all garden beds in fall. By spring, billions of organisms will have processed that material into living fertility distributed throughout your topsoil layer. Begin building your own by mixing finished compost with a 10% biochar addition and top dressing with worm castings at the start of decomposition. Amendment 7. Rock phosphate. The slow-release mineral reserve. Phosphorus is one of the 3 nutrients the synthetic fertilizer industry sells you. But the phosphorus in those bags is processed, water-soluble, and designed to perform quickly and disappear just as fast, often within weeks of application. Much of it bonds with soil particles and becomes chemically locked before roots can access it. The rest leaches into waterways, contributing to algae blooms and ecological damage downstream. You pay for phosphorus that plants never receive, and then you buy more. Rock phosphate is a naturally occurring mineral deposit formed from ancient marine sediments. It releases phosphorus slowly over several growing seasons, in forms that soil biology can process and deliver directly to the root zone. A 2021 meta-analysis confirmed that biochar significantly increases phosphorus availability and uptake, particularly in acidic soils, when combined with natural phosphorus mineral sources rather than synthetic applications. A 2025 PMC meta-analysis confirmed that phosphorus, potassium, and other nutrient concentrations improve significantly with natural mineral amendment combinations compared to synthetic single-application methods. The critical factor is, again, biology. Rock phosphate applied to biologically depleted soil releases slowly because there are no organisms to break down the mineral particles. Applied to soil enriched with worm castings, biochar, and activated compost, the microbial activity accelerates rock phosphate breakdown and delivers its phosphorus to roots within a single growing season. The 7 amendments in this vault are not independent products. They are an interdependent system. Each one makes the others work better. Apply 10 pounds per 100 square feet once every 3 to 5 years. Your soil stores the phosphorus reserve and releases it according to biological demand rather than a calendar schedule. But it survived. The knowledge never disappeared into corporate vaults or regulatory archives. While the synthetic fertilizer industry was consolidating into a $230 billion system, a quiet network of researchers, indigenous farmers, and stubborn gardeners preserved these amendments through generations of institutional neglect. University extension offices at Ohio State, Cornell, Michigan State, Texas A&M, and Mississippi State published field research confirming what ancient farmers knew before the word agriculture existed. Meta-analysis after meta-analysis, published between 2021 and 2026, documented what no bag of nitrogen has ever replicated: that permanent soil health grows from biology, minerals, and structure, not from synthetic chemistry purchased each spring. Terra preta sites in the Amazon produce extraordinary yields today, 2,000 years after their creators vanished. Green sand deposits supplied by New Jersey farmers in the 1800s continued releasing minerals for decades after a single application. Tohono O'odham farmers in Arizona preserved soil knowledge through centuries of displacement and colonization, and used it to restore harvests in conditions where modern commodity crops fail. They did not need a fertilizer company. They needed soil that worked on its own terms. Today, that knowledge is accelerating, not because the industry permitted it, because the research became undeniable, and because home growers, frustrated with expensive products that produced marginal results, started asking why ancient systems produced permanent ones. The silence around these amendments is breaking. You can grow what they silenced. Start with a soil test from your county extension office, usually $15 to $20, to identify your baseline and your specific deficiencies. Then build your amendment stack strategically. If your soil is heavy clay, begin with gypsum and green sand. If your soil is biologically dead and compacted, biochar and worm castings come first. If you are seeing mineral deficiency symptoms despite regular fertilizing, add azomite and rock phosphate. Then tie the entire system together with activated compost applied each fall. The total investment for all 7 amendments applied to a 1,000 square foot garden runs under $120. That is less than most gardeners spend on synthetic fertilizer in a single season, and these amendments do not leave your soil depleted at the end of it. Biochar lasts decades. Rock phosphate feeds roots for years. Worm casting biology rebuilds itself season after season. The $230 billion fertilizer industry profits from a cycle of dependency they designed. These 7 amendments break that cycle permanently. The knowledge was never lost. It was waiting in the soil, in the research literature, in the hands of farmers who never needed a bag of synthetic nitrogen to grow food. If this seed was finally freed for you, subscribe to Silenced Seeds and hit the bell. Every like and every share helps break the silence. The next seed breaks free soon.